Hi, I'm David Dusek, a senior writer with Golfweek, golfweek.com, as well as USA Today Sports. And I'm joined today by some people who know a heck of a lot about graphite iron shafts, which is a good thing because I don't know all that much about graphite iron shafts. So I'd like to introduce Avery Reed, who is the manager of tour productions for Mitsubishi Chemical. Avery, how you doing?
I'm doing good, David. Thanks for having us on today. I'm
Yeah,
looking
cool.
forward to diving into MMT.
Absolutely. And I've also got Tod Boretto, who is a composites engineering executive who played a big role in creating and basically conceptualizing the MMT graphite iron shaft from Mitsubishi. Tod, how are you?
Good, David. Thanks for having us. Appreciate it.
Yeah, I'm looking forward to learning a lot of stuff here. And before we dive into sort of a lot of the nuts and bolts of the stuff, Avery, the first question I've got is sort of the big sweeping one that I think a lot of people, when they think about graphite iron shafts, are going to have is that we've seen graphite iron shafts and graphite shafts in wedges here and there on the PGA Tour and the European Tour for a few years. And if you go way back, 2002, Rich Beem wins his PGA Championship. Yeah. He has 13 graphite shafts going. His putter shaft was made out of steel, but everything else at the point was graphite. It never really sort of took off. I thought for a little while there we might see some people really diving into that. We saw that with hybrid clubs. When Todd Hamilton wins, all of a sudden everybody starts carrying hybrid. It never really happened. Why are we starting to see now more and more players on the PGA Tour, the European Tour, the LPGA Tour, elite golfers being willing to even look into graphite iron shafts at this point?
Yeah, the MMT iron shaft's been a fun story. And to be honest, it was actually really interesting for us. It's been out for a couple years, but, this year at the Players, which is the best field of the year, probably the hardest tournament to win, we actually, between the utility iron and the iron sets, we had 10 players hitting MMT. We had 6 full sets, which is really unheard of, like you said. And, then following it at Valero, we had 13 guys playing it. We had 7 full sets in play. And I really think that comes down to 2 reasons. And number one, the technology. I think over the last 10 years, the advancement in the design and materials that we use in graphite has come a really long way. For a long time, it used to be the graphite, because of being a lightweight material, was always lightweight, high launch, high spin. But now, if you look at some of our recent product, we're using everything from aluminum vapor to MR70 metal mesh, and we're actually able to create the ball flight that these tour guys are looking for. And on tour, oh, go ahead.
No, please. Yeah, I don't want to interrupt the guy who's talking to me about tour stuff. Tell me more.
No, this year on tour, I think too, has kind of been a fun. It's been interesting, I would say, definitely. The talent out there is so great. These guys are so good. Even when you look at the Corn Ferry, these guys graduate and a couple of them will win right out of the gate. So right now, I think all of them are kind of searching for that one little secret that could get them an advantage over everybody else. And so definitely this year we saw, and it's been talked about a lot, we saw guys open to testing different things and new things, and it's kind of opened the door for us.
So, Tod, let's sort of take a look at it from your perspective. Where did the inspiration, if you will, and sort of the initial concepts for the shaft that would become MMT come from? Where did you sort of start at this point?
Good question. So it actually originated, Dave, in the archery division of Mitsubishi Golf. So we have a division called Victory Archery. We've been building arrows for years. And we started messing around with stainless steel in a carbon arrow to basically increase the mass of the arrow, but keep the diameter small for obvious benefits for wind deflection and so forth. And what we found by basically developing this prototype and highly developmental stainless steel mesh, by incorporating that into the structure, we're actually able to see a much faster response rate dynamically. So for an arrow, what's important is how once you shoot an arrow, it goes through a bending moment as it goes down range. If we can increase the rate at which that arrow recovers, we get a much more accurate arrow. So we knew that this material was actually dynamically responding faster than an all carbon arrow. Even given it was the same weight of the arrow, it was the same ID and OD, it was responding much faster. So what happened, Mark Gunther, who's our GM of our golf side, MCA Golf, saw what we were doing on the archery side and said, hey, let's try that out in a golf shaft. And that's how it started.
That's really interesting. So one part of Mitsubishi Chemical, which is working on a completely different thing, has nothing really to do with golf, is able to develop a technology or at least a design, manufacturing, it sounds like, way to do things that you can then go in and steal, which is a great way to do things because you actually,
Yeah.
and hopefully not get arrested for it, but
Right.
how often are you able to go through the different types of areas within this company and utilize technologies from other areas? It sounds like a great way for a big company to operate.
It is. It's a great opportunity. I'm like a kid in a candy store when it comes to Mitsubishi and their material breadth. Mitsubishi actually acquired Victory Archery back in 2014, roughly. And ever since that date, we've actually been collaborating on a number of different programs and projects. This just happens to be one of them. So between our tour department, which Avery runs, and collaborative working with him out on tour, getting that feedback from the tour level is just vital. It's so important. So we have all the necessary aspects to pull in information from the best players in the world, and in this case where we took technology developed in archery, we were able to transfer that over to golf.
And I bet, if you own an archery company, security around the building is probably not a problem. I'm thinking that the last thing somebody wants to do is all of a sudden there's 50 crossbows if you're looking at the windows wrong. When you were,
Right.
Tod, when you were developing the shaft and started going through the prototype, you've got this technology that's going to make MMT pretty special. It's going to do some things that you weren't able to do with straight graphite. Did you have elite players in mind as you're developing this shaft from the get-go, or is this something that has really sort of come out that is maybe a happy coincidence, but you really weren't thinking, let's get a graphite iron shaft with this technology for the best players in the world?
I personally, Dave, was not thinking of a specific player other than a general market segment. I think if you
Okay.
look at graphite irons, they've been highly effective in like the game improvement category,
Right.
but nobody has really penetrated that low handicapper, tour type caliber player with graphite. And from our perspective, we know the reason why, and we especially know it now because of what we've learned with MMT. But historically, in graphite irons, to get a graphite iron to play similar to like an X100 dynamic gold shaft or a steel shaft for that matter, we have to get the weight of the shaft up so the players don't feel a real lightweight shaft in their hands.
Right.
So that was the number one goal. And in historically, what's happened with graphite is to do that, we just end up putting a lot more graphite in the structure.
You make it
And
you make it thicker.
right, which
Yeah.
Yeah.
takes away the feel. So we can match the torque, we can match the weight, but then they don't feel good. So we've always strived to try and achieve that higher weight, low torque playability with an iron shaft in graphite without losing the feel and having it feel really boardy. And in this case, we accomplished that, but we also accomplished something really unique is that we're able to have and prove this out through our optical testing using high-speed cameras, is that the recovery rate of the shaft is much faster, just like in an arrow. So it actually transcended right over to a golf shaft.
So, Avery, then to you hear about this technology, you hear about this
Yep.
shaft sort of coming into development. When do you sort of translate that to, hey, I know some guys out on tour, we could probably seed this into the right types of players? When do you start hearing about this and thinking, yeah, let's bring this to tour?
Yeah, so that's a good question. We began with actually a prototype of it, and there are a couple players that have been pretty consistent at playing graphite all the way through. So the first people we went to was them, just to get feedback. And the feedback came back that this thing felt amazing, it performed amazing, and started to go and play. And then we took and during the off season, we went down to a facility, a bunch of us, Tod included, and we just wanted to get feedback. So that's kind of was our main goal, was research and development, was bring in a bunch of good players and see what happens. And what we started doing was we've started working with gears. So everybody's kind of seen on the tour, there's certain systems, there's TrackMan out there, and we can see ball flight, we can see launch angles, we can see spin rates. Gears is actually a system that's motion capture. So
Wow.
the best way to explain it is it's the same way they make the video games now. We have markers on the golf clubs. We have
Okay,
markers
cool.
all over the player. It turns it into a 3D system is what it does. And what that's given us the ability to do is really not only look at what the ball's doing, but look at what the shaft is doing, what the head is doing. And so instead of saying this feels good, we can actually understand why it feels good, how the shaft is loading, where it's coming in on impact. So it was kind of fun during the off season. We probably had about 10 top guys come down, and when we were testing the MMT iron, I mean, the first thing they said was, I'm not hitting graphite. It was that stigma
Yeah.
of this is going to go, especially with those guys, there's weight and they all have a window where they want to see that ball come out.
Right.
And graphite's really never been able to hit that window. And so they didn't even want to bother with it. But after, and Tod can attest to this, after the second shot with MMT, all the guys turned around and were like, what is this? And then we realized we've got something special.
Yep.
So at what point during sort of these different kinds of things, for a lot of people who may not be aware, back when I used to pre-COVID be able to go into a lot of the PGA Tour vans at different events,
Yeah.
when new products are coming out from the major OEMs, the original
Yes.
equipment makers, the TaylorMades, the Pings, the Titleist, Cobra, all that kind of stuff, when they make new irons, they try and, when they introduce them to players, make an exact replica to their spec, the same shaft, the same grip. The new
Yes.
variable is going to be the club head. They'll make sure the
Yeah.
swing weighs.
Right.
But when you're in these kind of environments now, and you're working with different shafts, and you are potentially bringing a whole new material and a whole new shaft to these players, what do you tell them in terms of like, hey, this is what you can expect to feel, this is what you can expect to see, that window that you talked about, you're gonna be able to hit that window? Or do you tell them nothing at all and let them just sort of experience it?
No, I mean, these guys are smart. And, like I said, this year they've been a little bit more open to testing. But I mean, over the past 10 years, these guys, they know what works and they know what they want. So if they're going to change into something new, data's key for them. So being able to go to them and show them, not only tell them, but show them research and data and show them, hey, look, this is face impact on the MMT. This is face impact compared to a steel shaft, and showing them that there's an improvement. That's where they'll start to listen to you.
And then how much does you describe this sort of gear system, which sounds really, really cool and very high tech. How much easier does it make your job when you can show them a visual? It's not just numbers. They've all become really good at reading numbers off of TrackMan or off of GC Quad and being able to equate a minus here, a plus there. But when you have a graphic, when you can see it, how much more powerful does it become for the players to understand, oh, this is what's happening in my swing?
Yeah. Oh, it's extremely powerful. And again, Tod can attest when we were down at the doing the testing during the off season. I mean, some of these guys, we would run through 8 to 10 different shafts. And then when you bring up a visual and you can show face impact location being consistent, I mean, with MMT, it was almost just like one single dot. Whereas when we would look at, steel, it was a little bit more sporadic. And when they look up and they see that, that's that edge that they think, okay, this is worth actually moving forward with and testing.
So that leads me perfectly to my next question for you, Tod, is I think that there is an idea out there amongst consumers and even probably amongst better players that from a consistency and manufacturing standpoint, being able to make a steel shaft is got to be easier than making a graphite shaft. Graphite has, as you described, many layers, many different pieces that are basically turned into one graphite tube. Whereas steel, I would just think like, it's one element. I make it however thick. It's going to be a lot easier for consistency's sake to make a steel iron shaft. Is that true? And how do you get around that when it comes to creating something like MMT?
Good question. And it is true, but they're completely different processes, right? So it's not
Okay.
fair to maybe compare one process to the other. Steel manufacturing for golf shafts has been around for a long time, as you know.
Sure.
It's a well-known, well-understood process. You're dealing with an isotropic material in steel, and that basically means steel has the same as most metals. They have the same properties in every direction. So whereas in graphite, we can tailor those properties, and we have a lot more flexibility to tailor a shaft to a specific consumer type or a category, much more so than steel. Their main limitation is wall thickness and where they put the steps as they go up the shaft,
Yep.
apart from the alloys and so forth. But with graphite over the years, in the past 30 years, we've made a lot of advancements in how graphite shafts are made. We've improved that tremendously, and that has really helped. I think from a feel standpoint, that's a whole nother subject of what a steel iron shaft player feels versus what they feel with graphite. And I don't know so much that consistency was maybe the main issue of what's held
Mm-hmm.
graphite shafts out of that market segment. I think it's been a lot of it's been feel and consistency in their shot dispersion, which can lead back to how the graphite shaft's made and how it's designed.
Sure.
I think we as a company, we've got a good understanding of that, and our methodologies and practices are really sound. So we make an extremely consistent product, whether it's a wood shaft or an iron shaft or a putter shaft. So, given that we've been doing this for years and years, we have a lot of experience under our belts. But it is a good question, and I think
So
consistency over the years has played a role.
So I've got one more sort of follow-up question in that you have when you think about, for example, the Tensei AV product, which is drivers, fairway woods, hybrids. Your wood shaft line. The AV stands for aluminum vapor, and consumers can
Yep.
see that at the top of the shaft, at the butt end of the shaft, and it's going to help to improve performance in a certain way. Now, MMT has stainless steel mesh that you've told us about. Now, are those two things sort of doing the same job, but just in different locations of the shaft? Because you're now infusing in two different shafts a metal or a metal type material. Are they doing the same thing?
To a certain degree. I mean, the
Okay.
aluminum is also it's twice the density of carbon. So you can place aluminum in a structure to get localized density and add some
Oh.
strength.
Okay.
The main difference, though, is stainless steel has a stiffness, a modulus, that's basically 3 to 4 times that of aluminum. So even though it's 3 to 4 times heavier than carbon or 2 to 3 times heavier than aluminum, it
Yep.
has a different elastic modulus. And what we found in our testing, because we did do some testing with aluminum in both arrows and in this particular shaft application for an iron, and the stainless steel, the response rate was superior. In fact, we couldn't really tell a difference between the response rate with the aluminum, the AV, but we did see it dramatically with stainless steel. And that has mainly the main reason for that is the elastic modulus, number one, the stiffness of the stainless steel, and its dynamic strain rate response. And that's what's happening here, though. Even that we can have two identical golf shafts that have the same bending stiffness, the same EI curve, the same weight, and we
Okay.
could put stainless steel in certain locations and certain design areas that those same identical shafts, one with the stainless, will have a much faster response rate. And our goal is to get that shaft to come back to its addressed position as fast as possible and stay there, which opens up that
Yeah.
window and gives you more flexibility. So
Which
that's
in
what we're doing.
which I would imagine in some ways gives you an advantage over a steel shaft because you can localize and really just sort of, it sounds like it's almost this recipe that you get to put together. And depending on where and how much of each individual ingredient you put in, you're going to get a different performing shaft, if I'm understanding you correctly. Whereas
Correct.
if you're going with one material and one type of steel going through there, you're going to get one type of performance based on the wall thickness, the overall weight, et cetera. It sounds like that working in this type of medium with graphite gives you the ability to really hone and dial in these shafts a little bit more than you can get with steel. Is that fair?
That's fair. That's
Yeah.
absolutely correct. Yep.
Okay.
And to speak on what Todd just said, on tour, that's exactly what we're seeing. I mean, the feedback from MMT with these guys, and these are hard hitters, is that club at impact returns to the same spot every single time and is extremely consistent.
So one of the things also that out there we're starting to get a little bit more into this is that there are actually two different MMT shafts, if I'm not mistaken. Avery, and I guess this is to you. There is a standard, and then there's also a taper tip. Can you explain to
Yes.
me what the difference is between that, and is that something for the consumer that they really, even at this point, because you're offering two, do they even really need to worry about that?
Yeah, well, it's an interesting question, and you are correct. So we have a taper tip, which is very popular on tour, and you'll see that in a lot of the better player irons, the muscle backs, the forged irons. But there's also a taper tip or the parallel tip. So the difference is really the bore depth or the hosel width. It's 335 or 355 to 370. 370 being the parallel and the 355 being the taper. And really what it boils down to is it's just easier to keep inventory for OEMs with the parallel tip.
Okay.
When we look at a parallel, when they designed parallel, they created one blank. So all the shafts are the exact same length.
Thankfully
And
for
what
you
you
guys.
what you do is to create stiffness, you cut from the tip section, and then to match the length, you cut from the handle section. On the taper, we have actually each shaft is matched up per iron. So a 9-iron shaft and an 8-iron shaft are going to be a 9-iron length and an 8-iron length. The problem is with these big with the OEMs is that inventory becomes an issue.
Yep.
So when you have one shaft that's all the same length, you can order 100 of them and pull 8 and make an iron set.
Yep.
Whereas if you ordered 100 of the taper tip, you got to order 100 sets. And so that becomes an issue. When it comes down to playability, these tour guys, like I said, their talent is unbelievable. And that's what they do. I mean, this is their living. They hit balls for a living. And for them, they feel that the taper is just a little bit more consistent. The one thing we do find, because on the parallel you're cutting from the tip and the butt section, depending on length, there is a descending weight effect that happens. So the 3-iron obviously doesn't have as much material being taken from it as the pitching wedge. So 3-iron ends up being a little bit heavier and it kind of moves down through the set. Your average consumer is not going to feel the difference,
Right.
but a PGA Tour player will. And so that's kind of why they stuck with that.
So this one, I suppose, is going to be to both of you. And Todd, let me sort of ask you first. This is not Mitsubishi's first foray into graphite iron shafts. You have had graphite iron shafts before, like, for example, Tensei. There is a version, a graphite iron shaft version of Tensei out there. What's going to be the difference between MMT and Tensei? I'm not saying that one is necessarily better or worse. It really comes down to the fitting for the specific player. But I would assume you're trying to achieve different things with these two offerings.
Yeah. So, I mean, obviously, it's one of those things you have to go get fit because there are so many options out there now. Like, I would never recommend driving a car without test driving it. I would also never recommend buying a set of irons without hitting them first. But yeah, the aluminum vapor irons are really good. It's just a different concept. So that's what we call ascending mass. Generally, what we do with those are all going to be taper tip. But what's going to happen is pitching wedge is going to be heavier, and then it'll start to get lighter as you go through the set, so that the 3-iron ends up becoming the light. It's just a little easier to pick the 3-iron up into the air, get a little bit more lift on the ball, which a lot of people struggle with. So depending on where you are weight wise, that might be a fantastic option. Or, if you're one of those guys that's always played a heavier steel shaft, the MMT is going to be the better option.
Todd, does that sound right to you?
Yeah, that sounds exactly right. I would add a couple things. It really, as Avery mentioned, it really depends on what market segment we're going after. So, for instance, a 115 TX, a 125 TX type shaft type player, your low handicapper, your tour type player. Um, I would highly recommend that they would check out and test the MMT version and compare it to an AV, shaft of similar weight. Because they're different technologies. They're both great technologies, but we're just on the early stages of MMT. We've had it under our belt now for about 2 years. We are learning constantly, and I see that progression, and we're seeing it also internally in our development, going through the entire product categories. We're doing woods, utilities, obviously irons, wedges, putters. And so we're based on what we've seen in the iron side, we have and are adapting that technology to our entire category line.
Yeah.
Yeah.
But we have seen on tour, where MMT almost, whether it's the 105 TX or the 125 TX, has been either too light or too heavy for the player. So we are seeding. We do have the Tensei AM, the white, out on tour as an option.
So I suppose that brings me to my last question. Really, I think, Avery, this one is going to be for you. If you are a custom fitter, if you're working at a golf specialty shop or a golf retailer, how do you know that a customer coming in or a potential client is going to be a candidate for something like MMT? What would be the 2 or 3 things that should go off in your mind saying, like, MMT could be a really good option for this player?
Back when I did all my club fitting, the candidate for the graphite iron shaft was the guy that had a really hard time keeping the ball in the air, needed to get flight, needed something light. The cool thing about MMT is I don't think there's a specific type. I mean, especially on tour, I mean, we have guys that are swinging really hard at it, that have it and play all the way through the bag. And we have guys that, you wouldn't picture playing it, and it's in play out there as well. So I don't think there's a specific candidate anymore, which is what makes this so much fun.
Cool. Awesome. Well, listen, everybody, I really appreciate Avery, Todd. Thanks very, very much for explaining and giving us so much good information about MMT. And if anybody out there has got questions about this that they'd like to get answered, go up onto social media, head over to Instagram. Mitsubishi Chemical Golf is the place on Instagram you'll be able to find and ask your questions there, or you can take it up on Twitter at MCG Golf Shafts. Those are the places where you'll be able to get lots more information, or talk to a good custom fitter in your local area. They'll also be able to hopefully answer your questions. Avery, Todd, thanks a lot.
Thank you.
Thanks,
Appreciate it.
Thanks a lot, David. Appreciate it.